All right, let's talk about gRPC. We're going to demystify this thing because it's a really powerful tool for solving one of the biggest headaches in software today: how to get all your different services to talk to each other without slowing everything down.
You know, it's a question that probably keeps a lot of developers up at night. We spend all this time building these incredible distributed systems, breaking down massive apps into these small, neat little microservices, and then, bam, you hit a wall. How in the world do you get them all to communicate without creating a slow, tangled spaghetti code mess?
Because the reality is you've got services written in different languages, you've got this constant need for real-time data, and just this non-stop chatter between all the parts. It's not just complex, it can get downright chaotic.
Which brings us right here to what I like to call the modern service maze. And yeah, that's a pretty perfect way to describe the landscape a lot of us are trying to navigate.
So let's make this real for a second. Imagine your data science team is cranking away in Python. Your main backend is humming along in Java, and some new, super fast service is being built in Go. That's a polyglot environment, right? So the big question is, how do you get them all speaking the same language and doing it fast?
Well, it turns out there's a much faster path through that maze. And that's where our hero for today, gRPC, comes into the picture.
So at its core, gRPC is this high-performance remote procedure call framework that originally came out of Google. But what does that actually mean, like in plain English?
This right here is the magic. It lets you call a function on a totally different computer like it's right there in your own code. It just completely hides all that messy, complicated network stuff from you. It's seamless.
So how does it pull this trick off? Well, it's got a couple of secret weapons. The first one, it's all built on top of HTTP/2. Now, this is not your granddad's old HTTP/1.1. This is a modern protocol that can handle tons of requests and responses at the same time over a single connection. It's just incredibly efficient.
And its second weapon is something called protocol buffers, or Protobuf for short. You could think of this as the actual language gRPC speaks. So instead of sending big, clunky text files like JSON back and forth, it sends these super compact binary messages. It's just built for pure speed.
Now when you put HTTP/2 and Protobuf together, you give gRPC some serious superpowers. Let's dig into what those are.
Okay, check this out. First, that binary format and HTTP/2 mean you get a massive performance boost over something like REST with JSON. It's just way faster. Then you've got this single contract file that gives you incredible language flexibility. So your Python, Java, and Go services can all work off the exact same blueprint. Plus, it has streaming built in from day one, perfect for real-time stuff. And because it's strongly typed, you catch way more errors before your code ever goes live. The whole package just feels like it was custom-made for microservices.
And get this, that streaming superpower isn't just a one-trick pony. gRPC actually supports 4 different kinds of communication. You've got your standard call and response, you can have the server stream data down, you can have the client stream data up, or, and this is the really cool part, you can have full bidirectional streaming, where both sides are just talking whenever they want. That level of flexibility is a total game changer. Okay, that all sounds amazing, right? But how do you actually use it? What's the blueprint for getting gRPC up and running?
It all starts with one thing: a contract. This contract lives in what's called a .proto file, and it is your single source of truth. Seriously, think of it like a universal translator that lays out the exact rules for how all your services are going to talk to each other.
And the workflow is just so straightforward. First, you define your service in that .proto file. Easy enough. Then you run a special compiler that automatically generates all the boilerplate code for your client and your server. After that, you just fill in the blanks on the server with your actual business logic. And finally, your client uses that generated code to make the call. It takes so much of the tedious setup work right off your plate.
All right, let's get to the main event. How does gRPC stack up against the undisputed champion of APIs for the past decade or so, REST?
So let's break it down. When you look at the data format, gRPC is binary, while REST is text-based with JSON. For transport, gRPC is on the modern HTTP/2, while REST is typically on the older HTTP/1.1. gRPC's absolute killer feature is its built-in streaming. For REST, it's that it's human-readable. And this really tells you where each one shines. gRPC is perfect for super fast internal communication between microservices, but REST is still the king for public APIs that people need to interact with.
And let's be super clear. gRPC is not a silver bullet that replaces everything.
REST is still absolutely the right call when you're building a public API and your users just expect plain old JSON. It's also better for talking directly to a web browser, and honestly, for simple services where being able to read the data easily is more important than raw speed.
You know, everything's a trade-off. With gRPC, the learning curve can be a little steeper because you have that whole code generation step you need to get used to. On the flip side, the challenge with REST is that it's just plain slower. And because it doesn't have a strict contract like a .proto file, it's easy for things to get out of sync between the client and the server. So, with all of that in mind, what's your next move? When should you be reaching for gRPC in your own projects?
Okay, here's the bottom line. Think about using gRPC when performance is absolutely critical for your internal services. Think gRPC anytime you need real-time streaming, like for a chat app or sending back system telemetry. You should definitely think gRPC when you're juggling services written in a bunch of different languages. And it's a fantastic choice for mobile apps, where its efficiency can actually save battery life and data usage.
And all of this leaves us with one last pretty big question to chew on. As our systems demand lower and lower latency, and as everything becomes more distributed, are we watching the end of an era? Is the time of human-readable APIs for machine-to-machine communication fading away in favor of hyper-efficient frameworks like gRPC? It's definitely something to think about.